Dear students, welcome to the online classes of endocrinology. Today I am going to explain about the endocrine pancreas. Here I will discuss about two hormones, insulin and glucagon. So first, the structure of pancreas. Here you can see the structure of pancreas. As you know, this pancreas can act both as exocrine as well as endocrine gland. The exocrine part of pancreas act in the digestive system. However, the endocrine part of pancreas secretes two important hormones, that is insulin and glucagon. So here in this picture you can see the TS of pancreas, and in the middle you can see the islet of Langerhans. And the islet of Langerhans mainly form three basic cells, that is alpha cells, beta cells and delta cells. Alpha cell secrete glucagon, beta cell secrete insulin and delta cell secrete somatostatin hormone. Here you can see the beta cell which releases insulin and it leads to decrease in the blood sugar level. However, the alpha cell release glucagon which lead to increase in the blood sugar level. Now the peptide structure of insulin. Here in this figure you can see the different domains of the insulin. Actually it formed as pre-proinsulin first, and here this is the structure of pre-proinsulin, which is made up of N-terminal domain, signal sequence domain, B chain domain, C chain domain and A chain domain. Once this signal sequence is removed, the pre-proinsulin can be converted into the proinsulin. And here you can see the proinsulin where B chain and A chain are linked by the disulfide bond. And finally the C chain is also clipped out, and finally the proinsulin can be converted into the insulin, and this insulin can be stored in the secretory granules of the beta cells. Now, how insulin secretion triggers in beta cells of the pancreas. So in this figure you can see the structure of B cell or beta cells. This beta cell has a specific transporter receptor which is called GLUT2, and when the blood sugar level increases or blood glucose level increases, this glucose can be uptaken by this GLUT2 transporter, and once glucose comes inside the beta cell, it can be phosphorylated by the glycolysis pathway, and it is converted into the finally ATP is generated, and ATP ADP ratio increases. Once ATP ratio increases, it can block the potassium channel. Once potassium channel ion channel blocked, it can create the depolarization of the cell membrane. Once the cell membrane is depolarized, means the potassium ion increases in the inner membrane side, the calcium ion channel get opened, and calcium ion can be entered from this ion channel, and these calcium ion can deplete the storage granules, and finally the insulin are released from these storage granules, and it is released into the blood. And once insulin released from the blood into the blood, it comes to its target cell. Particularly here you can see the target cell may be the liver cell, and the receptor for insulin are present here. When insulin is not attached to the receptor, it is inactivated. Once insulin molecule are attached to the receptor, it is activated. Once it is activated, it give various signal transduction, and it can activate the GLUT4 transporter or receptor. This GLUT4 transporter is important for the entry of glucose in the liver cell or target cell. So once this insulin receptor is activated, the GLUT4 is also activated. So glucose entry takes place, and this glucose is utilized by the insulin and it is converted into the glycogen or for the longer time. So it is clear from this picture that when glucose level increases in the cell, insulin released from beta cell goes to the target cell. Here you can see the target cell and the receptor of the insulin is present in the target cell, and the receptor is tyrosine kinase receptor. This is TR receptor. Once insulin is bind to the TR receptor, the tyrosine kinase get activated, it is phosphorylated at, and it can trigger the mitogenic function. It can activate the MAP kinase and further signaling pathway. On the other hand, it can also trigger the metabolic function. It can activate PI3 kinase, signaling and other signaling pathways like synthesis of lipid, protein, and glycogen. And it can also induce the cell proliferation. And more importantly, it can activate GLUT4 vesicles, and this once this GLUT4 vesicle get activated, it can send back to the cell membrane, and once it comes to the cell membrane, the glucose molecule can easily diffuse inside the target cell. Here you can see glucose molecules are entering through the passive diffusion, and once these glucose molecules enter inside the target cell, uh, they can be phosphorylated and utilized by glycolysis and Krebs cycle, and they generate energy, and excessive glucose molecule can be stored as a glycogen in the liver cell. So thus you can see how insulin can balance the glucose level in the cells. Now about the diabetes. Actually, deficiency of insulin can cause diabetes, and diabetes mellitus, commonly referred as a diabetes, is a group of metabolic disease in which there are high blood sugar level over a prolonged period. Symptoms of high blood sugar include frequent urination, increased thirst, and increased hunger. And if this disease left untreated, diabetes can cause many complications. And here you can see the type of diabetes. Actually, diabetes mellitus has two types: type 1 and type 2. Type 1 diabetes is called insulin dependent diabetes mellitus, that is IDDM, or it is also juvenile diabetes. The majority of type 1 diabetes is of the immune mediated nature, in which T cell mediated autoimmune attack the beta cell, and it can lead the loss of beta cell and decrease in the insulin production. Second is type 2 diabetes, and it begins with insulin resistance. Insulin resistance is a condition in which cells fail to respond to insulin properly, and as the disease progresses, a lack of insulin may also develop. This form of diabetes is called non-insulin dependent diabetes mellitus, or NIDDM, and it is a disease of adult one, and its primary cause is excessive body weight and not enough exercise. So if you will not do proper exercise and eat regularly, it can cause type 2 diabetes. A third type of diabetes is also reported, that is called gestational diabetes. It is reported in the pregnant women, and it is due to the excess weight before pregnancy. Now in this picture you can see the difference between two diabetes, type 1 and type 2. In type 1 diabetes, actually B cells of pancreas are attacked by the T cell, and finally B cell get degraded and the insulin production decrease. And when insulin production is decreased, glucose level is increased, and muscle are unable to use glucose due to the low insulin. The muscle is unable to take glucose due to glycogen and protein breakdown also, and it can cause ketoacidosis, and finally in ketoacidosis muscles are also unable to intake glucose. On the other hand, in type 2 diabetes, pancreas secretes sufficient amount of insulin, but muscle cells are unable to use the glucose due to the insulin resistance. Why muscle cell develop insulin resistance? Because of obesity or inheritance. So here you can see the difference between two diabetes. In this picture, you can clearly see the difference between two diabetes, type 1 and type 2. Uh, Only 10% of the diabetic patients are suffering from the type 1 diabetes, and 90% patients are suffering from the type 2 diabetes. As I already described, that type 1 is called IGDM, that is insulin dependent diabetes mellitus, and type 2 is called NIDDM, that is non insulin dependent diabetes mellitus, and it happens generally in the adults of overweight. Now, the cause of type 1, it is due to beta cell in pancreas are attacked by the body's own immune system, therefore reducing insulin production, leading to the elevated blood sugar level or blood glucose level. In type 2 diabetes, a high intake of dietary sugar lead to excess demands on insulin production, which leads to insulin resistance over the time. Now, the genetic basis of type 1 diabetes is possibly it is genetic disease, but not always. But type 2 diabetes is always linked to the heredity. Now, bodily effect of type 1 thought to be triggered by autoimmune destruction of the beta cell in type 1. In type 2, it appears to be related aging, inactive lifestyle, or diet and obesity. So if you will eat regularly and if you are not doing proper exercise, it can lead to the type 2 diabetes in adults. Climate, if you will we discuss about the climate. Type 1 diabetes develops more often in winter, and type 2 diabetes is more common in people with low level of vitamin D. So sunlight is also play important role in the management of type 2 diabetes. Now, dietary habit. Early diet may also play a role. So type 1 diabetes is less common in the people or children who were breastfed, and in the case of type 2 diabetes, diet high in simple sugar and low in fiber and vital nutrients are more likely to lead to type 2 diabetes. Now here in this chart, it has shown that what should be the normal glucose level in the blood. So if a person, in a normal person, blood sugar level should be 70 to 100 milligram per deciliter during the fasting, and after taking meal it should not reach beyond 140 milligram per deciliter. However, in diabetic patient during the fasting the level goes up to 125 mg per decil, and after the meal it can reach up to 200 or more than 200 milligram per deciliter. Now in this chart you can see the level of insulin, which is shown in blue line, and level of glucose in normal person. So here during the breakfast or after the breakfast the level of glucose goes up. Similarly, the insulin level also goes up during the breakfast or after the breakfast. Similarly, after the lunch, both insulin and glucose level go up, and similarly, after the dinner, both glucose and glucose and insulin level goes up. So this is chart for the normal person. So now there is a important or some interesting story behind the Nobel Prize controversy. Actually, in 1923, the Nobel Prize for Physiology and Medicine was awarded to scientists of University of Toronto in Canada. And the names of these two scientists were Benting and MacLeod. But Benting was not happy with this decision because his uh, colleague Best was ignored. So he shared his Nobel Prize with Best. At the same time, MacLeod also feel his colleague was not recognized. So he also shared his Nobel Prize with James Collier. So finally, four scientists, Benting, Best, MacLeod, and Collier, got the Nobel Prize. And due to this controversy, the patent for insulin was sold to the University of Toronto for only $0.50. And later on, the British molecular biologist Frederick Sanger sequenced the protein of insulin, and he also got Nobel Prize of Chemistry in 1958. Here down in this chart, you can see the three important hormones of pancreas, that is insulin, which is secreted from beta cell. It intake the glucose and it is helpful in glycogenesis and glycolysis. The hyposecretion of insulin leads to diabetes mellitus, and hypersecretion of insulin leads to the hypoglycemia. Second important hormone of pancreas is glucagon, which is secreted from alpha cells, and it is helpful in glycogenolysis, and hyposecretion leads to hypoglycemia. Third hormone is somatostatin, that is secreted from delta cells. It inhibits both release of insulin and glucagon. Now the mechanism of action of glucagon. So second important hormone of pancreas is glucagon, and once the cell observes the shortage of glucose, the alpha cell of pancreas starts secretion of glucagon, and glucagon released in the blood and it comes to the target cell. Particularly here, target cell is shown, it may be the liver cell, and in the target cell, the receptor for glucagon is present, and the receptor is GPCR receptor here. Previously, we have seen that the receptor for insulin is tyrosine kinase receptor, but here the receptor is GPCR receptor. Once glucagon is bind to its receptor, it can activate it. After activation, it can further activate the adenyl cyclase, which convert ATP into the cyclic AMP. This cyclic AMP can act as a secondary messenger. It can phosphorylate it can activate various protein kinases, and after protein kinases get activated, they can phosphorylate various enzymes. They can activate specific enzyme or inactivate specific enzyme. After activation of specific enzymes, the glycogenolysis is happen in the liver cell, and glycogen is converted into the glucose. So glucose level increases into the cell. So here you can clearly see, once glucose level goes down, there is a role of glucagon to increase the blood glucose level or glucose level in the cells. And finally, here in this picture, you can see how glucose is balanced by insulin and glucagon hormone. Here from right side, you can see once you eat, there is increase of blood sugar level. Once blood sugar level increases, the pancreatic beta cell start releasing the insulin, and once insulin is released, it can utilize the glucose and convert it into the glycogen. On the other hand, when you exercise more, your blood sugar level decrease, and once it is decreased, the pancreatic alpha cell start secretion of glucagon, and glucagon goes to the liver, and it can break down the glycogen into glucose again. So thus you can see the glucose is balanced into the human body or any mammalian body by these two hormones. That's all about the um, pancreas or hormones of the pancreas. Next time or next week, I will start a new topic. Till then, please stay at home, stay safe, and if you have any query, you can write me on my WhatsApp number. Till then, goodbye. Take care.